Okay, welcome back. So we're having a look at the area enclosed by each parabola and the x-axis. So this is quite an important idea because it assumes that there's some intercepts that go on the x-axis, and that also tells us that's the key to resolving the limits of integration. So x squared minus 9 is an x squared shifted down at 9. And so it's got this lovely shape up here that we're familiar with. And then whatever they are, we have to work them out. And the way that we work the intercepts out is that we solve, don't we? We take those and we solve them assigning y to 0. So undo. So x squared is equal to 9. Undo both sides. So x is equal to plus or minus the square root of 9, which is plus or minus 3. So that's the interval, minus 3 to 3, that we're looking at, and they form the limits. Okay, so we're going to integrate x squared minus 9 dx between minus 3 and 3. That's how we'll do that. So up and under becomes x3 on 3, where before there was no variable. Now there is between minus 3 and 3, and we did that by the fundamental theorem of calculus. So then we set our scaffolding up. We've got two rather large sets, because we've got a few terms, a couple of terms in each. And just having the discipline, please, to go through and put all of them up. Okay, minus 3 is going to go in those, 3 will go in those. So just a reminder, we'll put a minus 3 in here, a minus 3 in here, a 3 in here, and a 3 in here. Now notice this is an odd, so that's going to stay. So we'll end up with 3 3s are 9, 3s are 27. 27 on 3 is 9, minus 27. Now, this will be minus 3 3s are 9, 3s are 27. 27 on 3 is 9. And this is minus times a minus, which is a plus. So we'll get plus 27. So a bit unexpected in terms of values, but nevertheless, we're happy with that. Alright, so the next thing to do is we can start removing brackets, but not before we've done an expansion. Minus times a minus is a plus. Minus times is minus 27. So we've got 9 plus 9 is 18, and minus 27 twice is what? Minus 40, minus 54. So 54 is one of those factorizables. So I'm going to add 20 would be 40, 34, plus 2 is 36, so it would be negative 36 units squared. So the negative just informs us that for x squared minus 9, this is the area between the x-axis and the curve. In other words, it's underneath the x-axis. Okay? And we can have a look at that. I think I'll put them in there as well. A bit further down, perhaps. X squared minus 9 is the area between the curve and the x-axis. Okay? Alright. So for part B of 2, we're looking to understand curve minus 5x minus 6. Now I think in the workshop video I went to great lengths to, I don't know what this looks like, but I think I went and sketched it. If you want to sketch it, you can. You've got the skills from Foundation Maths. You can complete the square, and that'll completely show you where that's at. So I'll do that over here. Y equals x squared minus 5x minus 6. Set it to 0. Minus 5 times a half. Square that. $25 on 4. That's the square number that goes together with this pair. x squared. I know I don't need to do this. I don't need to do it all. But I'm doing it because I love doing it. And I was showing you how important it is. Can't just add willy-nilly, so you have to minus as well. And what about your 6? And don't forget that. Alright, so this is a perfect square like that. Check it. X squared times 2, tick. Squared is that one. So this was the hard bit, 25, 4. So 25 minus 6 4s are 24. So it would be minus 49 on 4. So 49 on 4, so it's at plus 5 on 2 shifted down. At plus 5 on 2, 2 2s are 4, so that's 2.5. And shifted down here, 49, which is what? 4, 12 and a quarter. Okay, and at that point there, then it goes up and minus 6. It goes up like this. And what we're missing, of course, is the things there. So we can do the quadratic formula. We can finish doing this. It's a monic, so it shouldn't be such a big deal. So I'll put 49 over the other side. Look, I'll skip a few steps for you. So we'll have 5 on 2 added. We'll have plus or minus square root of 49 would be 7. And the square root of 4 would be 2. So I've kind of done a little bit of that for you. So 5 and 7 is 12 on 2, which is 6. And 5 minus 7 is minus 2. So it's minus 1. Now we could have done the whole thing like this, but I want you to value completing the square because it is an answer. So therefore x equals 6 and minus 1. So in order for that to be 6, that's got to be minus 6 and that's got to be plus 1. So let's check it. X squared, yep. Minus 6x plus x, tick, tick. So we're all set. That's correct. So that's the integrals. Limits of integration, minus 1 to 6. So we're just going to integrate between there and there. So we integrate between minus 1 and 6, x squared minus 5x minus 6 dx. And that'll give us up and under. Between minus 1 and 6 by FTC. Okay, so that's completing the square. I skipped a few steps, a bit naughty of me, but you get used to it. You'll do the same. So for this one here now, it's the scaffolding, which will be quite long. For minus 1 and for 6. And so we'll get the bare bones. And repeat that. Lots of discipline needed, isn't it? Okay, lots of discipline needed. So put the minus 1s in. That's going to stay because it's an odd power. Put the 6s in here. Alright, so then we can start to put that together. 6 6s 36. 36 6s. Getting a bit tired now, 36 6s. 6 6s are 36, 6 3s are 18, 19, 20, 21. So 2 1 6 on 3. 6 6s are 36 times 5. 0 D, 5 5s are 25, 30. 5 3s are 15, 18, 180. So minus 180 on 2. And minus 36. Now that's going to stay as a third, so minus a third. But it's minus minus a third, so it's plus a third. I'm doing that step straight away. Minus squared becomes a positive. It's only 1, so it's 5 on 2. It's minus, but it's minus times a minus because of the expansions. So minus plus 5 on 2. And finally we've got plus 6. Okay, and all of that should come together. Look, how do you do that? It's just drudgery, isn't it? I can do it by hand. I know I can, and you know I can. But I'm not going to do that. I'm going to do this. 216 divided by 3 minus 180 divided by 2 minus 36 plus 1 divided by 3 plus 512 and plus 6. So we've got minus 45 and a sixth units squared. And so this one is, as drawn, the area under the curve. So it's a negative. So we did well in all of our interpretations. And if we go and look for that one, that was quite a long one because it involved a quadratic, but what are we doing? 2b. 2b with this one here. Here it is here. So we've got that same thing there. Now why is that different? 343 on 6. 45 times 6. Let's just have a look. 5 5 takes us 30. 6 4s are 24, 25, 26, 27. Oop. I must have done something wrong. 343 on 6. Why did you do 343 on 6? $57 on 6. So something's got a miss there. That's alright. Let's go back and find it. What have I done? 6s are going in here, cube. That's all okay, I think. That's fine. 5 on 2, 5 on 2, 6. 6s. Minus. Okay, let's just try again. 216 divided by 3. Let's just put it in the memory. Let's do it that way. 180 divided by 2. Plug it into the memory. 36. Add it to the memory. 1 divided by 3. Add it to the memory. 5 divided by 2. Add it to the memory. 6 memory plus. Put the memory back. I'm getting the same answer that I got before. Okay. Clearly come unstuck. Okay. 216 divided by 2. 16 divided by 3. 72, so that's correct. Minus 90, minus 36. Everything's right up to it, but not there. Okay, can you see what I did there? That should have been a plus, and that expansion should have made that a minus. So there's my error. So it's good that I found it, and it's good that you saw me finding it, because it's important. You know, these are the kinds of mistakes that come up. So it's not a matter of accusing myself of being careless. It's just what happens when you process this. So let's do it again. Clear the memory. I won't do the memory version of it. I might do the memory version of it. That seemed to work well. 216 divided by 3 equals, put it in the memory. 180 divided by 2, that was the minus. Add that to the memory. 36. Add that to the memory. What do we have? 1 divided by 3. Add that to the memory. 5 divided by 2. Add that to the memory. And then minus 6. That's the bit I made a mistake in. Add that to the memory. Let's get our memory recall. That's better. That's much better. Minus 57.16 repeater is minus 57 and 1/6 units. So we got there in the end. Corrected the mistake that I made for that silly 6 And that's good. It's good that you see me doing stuff like that. All right, let's have a look at C. I think we've still got time. It's just 15 minutes, so we'll do C. And we've got y equals 1 minus x squared. So it's x squared shifted up to 1. So it's at 1 shifted x squared. And so we're going to be getting whatever that is. So we've got to solve. 1 minus x squared is equal to 0. So we'll add x squared to both sides as undo. Take the square root of both sides. So we'll get x equals plus or minus the square root of 1, which is plus or minus 1. So we're going to be integrating between minus 1 and 1, 1 minus x squared dx. And if we go ahead and do that, we'll get an x where there wasn't one, and we'll get x3 on 3 between minus 1 and 1. So we're able to do that. The calculus doesn't take very long. Then we're going to set the scaffolding up. So we've got cube on 3. Don't be lazy, just do it. We're going to bomb this one with minus 1s. We're going to drop in 1s here. So they'll get 1s. Be careful now, because I made a mistake last time, didn't I? So that's just 1 minus 1/3. We've got to do the expansions on 2, but this is minus 1, so it becomes plus 1. Now, this stays, because this is an odd power, this is still minus 1, but we have a minus, so that minus makes a plus, but that expansion makes a minus. That's the mistake I made last time. So we've got 2 minus 2/3. I know you don't like me doing that. 2 minus 2/3 is 1 1/3, which is 4 on 3 units squared. So that should be fine. There it is, 1 1/3. Okay, so I'll pause there. That gets question 2. We'll come back and do question 3. We'll be back soon.